Ischemic injuries are one of the leading causes of death and disability worldwide. Essentially, those are conditions where metabolic requirements cannot be adequately sustained by bloodstream delivery of oxygen. One way we have to defend ourselves against these conditions is to cool down. A temperature reduction, in fact, results in the suppression of metabolic activity, partially resolving this imbalance. In a clinical practice, therapeutic hypothermia is used exactly with this intent, and it actually works pretty well. Currently, though, we're limited to a mild degree of hypothermia. By forcing the organism to cool down, in fact, it's only possible to decrease body temperature by a few degrees before activating potentially harmful responses aimed to the restoration of normal body temperature. However, in nature, there are some animals, like marmots and squirrels, that are actually able to almost completely shut off their metabolism, entering a sort of energy-saving mode. And this also allows, obviously, to reach very low body temperatures. This state, called torpor or hibernation, is completely, spontaneously, and safely reversible. The possibility to exploit such a mechanism would be of great interest in order to improve the effectiveness of therapeutic hypothermia, if only humans were hibernators, which unfortunately isn't the case. Neither rats are hibernators. Nonetheless, as discovered in recent years in our laboratory, by the manipulation of a specific brain area, it is possible to induce the expression of a state very much resembling natural torpor in non-hibernating animals, such as rats. This state, called synthetic torpor, if induced in humans, could represent a way to overcome the limitations of current therapeutic hypothermia protocols. Before moving on to translational approaches regarding the possibility to induce synthetic torpor in a human being, obviously it's necessary to assess the safeness and the safety of our model in terms of reversibility and of a full structural and functional recovery after the return to normothermia, as it happens in natural hibernators. Evidence is collected so far point in that direction, and the aim of my PhD project is to deepen and expand the already existing knowledge. Basically, what I'll be doing will be to evaluate cerebral cortical connectivity, neuronal morphology, and cognitive functions in rats before and after the induction of synthetic torpor in order to assess whether the recovery from the condition is complete under these aspects. So, are we cool enough? Not yet, but we're working on it.